With the rise of food deserts, food insecurity, population, and the need to be sustainable, aquaponics have become more and more popular for agriculture. What is aquaponics? Aquaponics refers to any system that combines conventional aquaculture with hydroponics. Aquaculture is raising aquatic animals in tanks for food. Hydroponics is the cultivation of plants in sand, gravel, or liquid with added nutrients, but without soil. However innovative the use of aquaponics is, there has been evidence of hydroculture present throughout history. Hydroculture is the growing of plants in a soilless medium or an aquatic-based environment. The Aztecs developed a system of floating gardens, called chinapas, out of necessity around 900 BC. They were unable to grow crops along Lake Tenochtitlan because of its marshy shore. They built rafts out of reeds and roots. These rafts were topped with some soil from the lake and then floated out to the center of water. Crops would grow on top of the rafts. Their roots reached through the rafts down toward the water. There is even evidence of aquaculture in China. About 3500 BC, carp were cultured in paddy fields, providing nutrients for rice crops. The utilization of modern aquaponics is a viable answer for urban agriculture where land is mostly used for development as opposed to traditional agriculture. Because space is limited, aquaponic systems allow for fresh foods to be grown close to where people are. This method is economically efficient, for it only uses 1/10 of water comparing it to classic agriculture. It can address food deserts as well, for it can provide bountiful harvests for areas with low access to fresh produce. With aquaponics, fish are raised in one tank and produce in another. The fish are treated humanely, being fed and provided a safe environment to live in. Fish, as with any living creature, produce waste that can be translated into a nutrient-rich solution that becomes fertilizer for plants. The fish are creating ammonia in their waste product, which is broken down in a two-step cycle by naturally occurring enzymes and beneficial bacteria. The ammonia is converted into nitrites. Then, the nitrites are converted to nitrates, which the plants can absorb. Without the beneficial bacteria, the aquaponics system could not function because the ammonia that the fish produce is harmful to both the fish and plants. With the exception of added fish feed, aquaponics is a self-sustaining ecosystem. One method of aquaponics is media-filled beds. Media comprised of rocked or expanded clay fill containers where the plants are grown, and thus called the grow bed. Water from a fish tank is pumped to the grow bed where the roots of plants absorb nutrients and water. The plants and media also serve as a filter for the water, making it safe for the fish. The filtered water is then flushed or flows back into the fish tank where the cycle continues. Another method of aquaponics is deep water culture. Like the Aztecs' chinapas, plants are floating on the top of the water, where the roots are hanging down in the water. Integrating aquaponics in the classroom is a great way to raise awareness for agriculture and sustainability. As agriculture becomes less and less relevant, and the world becomes more technologically driven, the youth does not know or question where their food comes from. The process of everything related to an aquaponics system provides a plethora of teachable material that can easily fall into learning standards in every content and grade level from K through 12. Aquaponics can be a great tool for STEM. The multiple sciences can relate to an aquaponics system with a living lab to access for the classroom. The technology involved in construction, maintenance, and observations are limitless. Fostering critical minds for problem solving is essential for repair and troubleshooting if and when anything happens to the individual system, making the engineering process and scientific method one. The possibilities for mathematics with aquaponic systems can range from simple counting to calculus. There are many social and global issues that aquaponics could solve: hunger, reduction of arable land, and even unemployment. Students can learn of social impacts of unstable conditions in social studies and language arts through reading text, nonfiction, and fiction. Relevant news, articles, speeches, and video can be examined to further understand the use and purpose of aquaponics.